Okay, as Greg said, our webinar today is our rainfall and pasture growth, comparing current seasons with the past. It's webinar 2 in Getting the Inside Edge in Grazing Land Management series. On behalf of the Grazing Land Systems team, past and present, Long Paddock is the site where all this material from this webinar is taken from. We're going to have a bit of a roadmap here so we know where we're heading. I'd like to sort of relate that there is a storyline in the webinar. So firstly, we're accessing the new rainfall poster page. We're then going to talk about our original Australia's variable rainfall poster, move to Queensland's extended wet and dry period poster. We're going to do a sequence of drought situations, then look at some climate drivers for drought. A few terms here: ENSO, El Nino and La Nina, made up from the SOI, Southern Oscillation Index, the pressure difference between Tahiti and Darwin, and one that you may not have heard of previously, the IPO, Interdecadal Pacific Oscillation. If you haven't heard about it before, you will have heard it a number of times through this webinar. We'll talk about how that some of the information is in Learning from History report. Another 2 posters that we have, the Tropical Cyclone and Pasture Growth annual posters, where you can get a lot of that information from yourself in the Aussie Grass Maps and Data. And then our latest poster visualization, what we call the Map app. Moving on, our new rainfall posters page, just updated recently. Here it is, and on the way you get to it from the Long Paddock website is up on the top tabs bar here. You go straight to the rainfall poster tab. It'll bring you up with this page. First thing we'll see here is our original description for our past poster there, the Australia's variable rainfall poster, and a link that will take you straight to that PDF of the poster. However, seeing we've added 3 more posters, the series are down below here, all as clickable links. They're quite big files and take a little bit of time to download. Up here we have a link for downloading the most recent updates for those posters, so that you can download, print those out, and cut out the maps to add to the posters that you already have, and that makes them live on, and you can keep them on your walls. Lastly, here we have our rainfall poster map app, and we'll talk about all of these as we go through the webinar. Now, Australia's variable rainfall poster. This is our original, and we're going to unpack it a little. So from the title here, April to March annual Australian rainfall relative to history. So we take the rainfall from April to March so that we can cater for the Northern Australia wet season, so that it's all in the one year when we analyse it. Relative to history, historical records means that we are taking each pixel, each 5K pixel, and relating it to that pixel right across history, and we do that from 1890 to the latest year. So top left here we have the first year, which is 1890, right across to the most recent year, 2018. Now, if we look at the colours of the years here, a red year represents El Nino, the blue year represents La Nina, and the grey blacked out one is neutral year. And the neutral years are not average years, they're just not El Nino or La Nina. And anything can happen. You can have dry years or wet years through those. Now, the descriptions for those, the definitions are on the right-hand side here on the sidebar, and we use the percentiles to rate the years, and we'll keep this same color code throughout all the posters here, where your blues down to your greens are your wetter rainfall years relative to history, and your yellows, reds, and browns are your driest relative to history. Okay, so let's look at some of those years. Now, if we sort of look at, everybody has their favourite sort of run of wet and dry years. If we look at the wet 70s in Queensland, we've got a run of 6 or 7 years here where we see flooding and towns inundated like Baduri here. We also, in the 80s and the 90s, have dry years, and we see western regions that might look like this. Okay, our recent 6-year period, and started from 2012-13 here, and we've got 6 years, and the question mark means when will that sequence end? Down underneath that, at the bottom here is the areas where we can stick the extra maps from extra years. Okay, moving down to the time series here. On the left, we have the axis, we have the SOI, the Southern Oscillation Index, and it's the darker colours, the dark blue and the dark red. And the timeline here is what we call an anomaly. So everything above the axis here is above average, and below is below average along the line here. And it's a 6-month moving mean, while the other axis we have here is the IPO, the Interdecadal Pacific Oscillation, a much slower extended period is the IPO, and we're going to explain that a little bit further as we go along. But suffice to say, it's an 11-year moving mean, so it's longer and slower here. And we're going to talk more about how it interacts. We've got periods of history here. If the IPO and the SOI are both acting in the same way, you'll get a double-up effect, and that's like this 1970s here. So that corresponds to the 1970s here. You get an additive effect, and you'll get a double wet impact. Now, similar when we go down below the line here, and we call that side of the IPO the warm phase, and when it's with the negative SOI, we have that dry, but double dry, that additive effect of dryness here. So we call the IPO with the positive SOI, we call that the cool phase, and we're going to talk about that a little bit as we go along. So, seeing we've isolated some of those wet and dry periods, we've gone along and done that for the whole time series. So let's go through this again. This is for Queensland, the extended wet and dry periods. Why Queensland only? Because we have we can only isolate it in terms of a locality for the wet and dry periods. It's still April to March rainfall, and it's still relative to history. So over here, if we start at the sequence there to 1889, it's a 7-year wet period, and the background here is bluer for wet. It'll give the years here, and then we moved on to a dry period, which is the Federation Drought, a 7-year dry period. Again, we change the colour coding here. So we go from a wet, dry, and those years are varying. And if we come to the most recent period here, a 6-year to date, we might sort of look here and say, oh, it's a 5 and 6 year sort of sequence, maybe up to 7. No, it can be 9 years wet, 13 years dry, 11 years dry. So we shouldn't be thinking in terms of having 3 to 4 dry years, it must rain. It doesn't have to. So we're going to have a look at some of the annual years, and you should use that annual rainfall poster in concert with this wet and dry one, so you could see what the individual years are made up with this. The text underneath are notable contextual occurrences, social, climate, and economic, to put the periods in context. Down below here, we have the SOI IPO time series, the same, and you can have a look at how both of those are interacted with that particular dry period. So let's talk about a period that we know about, and that's pre-Federation, a very wet period here, 7 years, and our Federation drought, 7 years, and compare it with our most recent wet and dry period, post-millennium drought, a 5-year period, and our current dry year period to March this year. Now we're going to have a look at how the drought sequences have interacted, and from this period on here, from post the millennium drought, moving into 2008, we look at the drought situation here, and we're just to show that we don't, once the tap turns on, that we don't get out of drought immediately, and it takes some time for drought declarations to be removed and revoked. So into 2010, we've got still a couple of shires here that are declared, and 2011 we're out of drought, and 2012, and we're right at the end of this period here, this wet period. And moving into the 2013, we're moving into this dry zone here, but it's always surprising to see how quickly the drought declarations build up, and within that same point in time, later in the year, in October, November, we'll go to the year and of 2013, and more than 50% of Queensland is drought declared, which is really surprising that it happens so quickly, and it surprises a lot of land managers too. 2014, it starts building up to a peak of 80% declared in 2015, comes back a little bit, 2017. The current situation is October, 58% declared. So that just to highlight that it's easy to get into drought. It takes a lot longer for shires to move out of drought. Now, the place we get those drought maps from is on the long paddock. It's under Drought Declaration tab here. I would go to the Drought Declaration archive, which brings up this screen here where you can nominate the month and year of map that you would like, and then you get this. You can get a color map by pressing on this button here, and save them if you wish, and do the same as I will. But we're planning to have a little app that will bring up the sequence of drought declared maps with rainfall and pasture growth later this year. Okay, the Bureau says we're in El Nino alert country. Now, is El Nino acting alone, or are there other drought climate drivers at foot? So I took this off an ABC weather post the other day, a very good graphic showing El Nino coming in here from the east for our summer rainfall, but we've got southern annular mode kicking around here for winter, and a positive Indian Ocean dipole from the west here, coupled with a weak monsoon, all adds up to us having a reduced summer rainfall season. But there's very little said about the IPO, the Interdecadal Pacific Oscillation. So I just thought I'd introduce that to you a little bit. A paper by Ben Henley in 2015, the University of Melbourne, describes the location that that an index can be taken across here through three locations here in the Pacific. And if I was to summarise the IPO, it'd be that it's related to a movement of warm water in the Pacific Ocean. Its pattern is similar to ENSO, and there is conjecture about the amount of linkedness it is with the El Nino Southern Oscillation, that whether it's just a slower moving artifact or whether it's its own being, but it's certainly operating on much longer time scales, 10 to 30 years, as opposed to the ENSO, which is 2 to 7 years. The warm phase, as I said before, positive IPO is detrimental to our rainfall. The cool phase, negative IPO, is beneficial for our rainfall. The phases have an additive effect with ENSO when in synchrony, and I showed that to you on the rainfall poster first up. But let's have a look how they interact with our sea surface temperatures here. Okay, so here we've got six maps of sea surface temperature. This is the El Nino pattern across here, these two here, where we see this tongue of warm water stretching over to Australia. Okay, that's two examples. La Nina is where the opposite, where we get these cool tongues coming across to Australia, giving us higher rainfall. Neutrals in the middle. And as I said before, anything can happen with the neutral situation. Okay, so let's add something to the columns. This column here is when we have the IPO cool situation, beneficial for us. IPO warm is detrimental to our rainfall, and I'll show you the opposites here, where we have an El Nino and an IPO, a warm IPO, and that's when we get our killer droughts, our worst droughts. The extreme opposite to that is when we have an IPO cool and the La Nina, and this is when we get our wettest wets. Suffice to say, if we have this warm IPO, it will dampen down and even give us a failed La Nina. Likewise, a cool IPO will actually will soften an El Nino. Okay, let's have a look at the rainfall, how it impacts on our rainfall. These are taken from learning from history. I'll show that in a couple of slides. So same setup here with the patterns, with the ENSO, El Nino and La Nina on this axis, IPO, cool and warm across here. Okay, so this is the rainfall from the composite maps. That's just a number of like type maps all put together. And that's our extreme rainfall here. That's the deficit of rainfall that we expect with a warm IPO and an El Nino situation. And this is our La Nina with a cool IPO, and showing that it's watered down a little bit here. La Nina when we have the warm IPO, and the El Nino drought is tempered by the cool IPO here, not as severe. Okay, the Learning from History report, put out in 2004, 256 pages. Chapter 1 describes climate and economic forces and interaction with rangeland grazing systems. That's where I took those last two slides from. So if you want to read more about how they interact with Australia and Queensland's weather, that book's available on our Long Paddock website. Chapter 2 describes the degradation and recovery episodes in Australia's rangelands of eight episodes from Federation drought onwards. You would access that by going to the Long Paddock website, going to About, and then Useful Resources, and scroll down and you'll see the pasture degradation in Australia's rangelands link here. Will take you to that. You can download the whole 256 pages. There's two more chapters there that I didn't mention. One's on shrublands and the other's on the long-term analysis of two Western Queensland properties. There's also a webinar available there on relating the science and this situation to artists like Sir Russell Drysdale. So a good read if you want to go and visit that. Moving along, we go to our Australia's variable rainfall poster with tropical cyclone tracks. The information around it is still the same. We go from 1 year in the past to the most recent year. We have a sidebar that explains all the classifications, and we still have our IPO SOI time series down the bottom here. The cyclone tracks have been imported from the Bureau of Meteorology. There's fewer cyclone data around the early years, so this doesn't go back as long as the variable poster, the original variable poster. Now, if the cyclone tracks cross land, the line gets thicker. And here's an example of the last few years here. As the cyclones cross the coast, the line gets thicker. If they cross the eastern coast here, we put actually put the names here, so you can keep track of them. So Yarsi's in this 2010-11 year, and we come down to 4 down in this 2013-14 year. What I'd just like you to relate to you that just the haphazard and chaotic nature of the cyclones, that they may or may not break a drought. So 2 La Nina years here, and their contribution of the rainfall is quite stark here, where this is only slightly above average compared to history, the rainfall in the 2011-12 year. We have a neutral year where even though Oswald travelled right down the coast of Queensland here, and giving some relief and a lot of damage, most of Queensland here still in deficit of rainfall, like 2013-14, and adding the most recent years here, a mixture of La Nina and El Nino years here. The most recent year here, a failed La Nina, no cyclones at all. Okay, so that's the main point here, that cyclones may or may not break your drought situation. Moving along to our pasture growth poster. As explained in the previous webinar, we run a pasture model to explain how rainfall is turned into primary production. Similar setup that we go from 1890 here to 2018. So each year is matched with the Australia's variable rainfall poster. This is modelled pasture growth data. And if we look at the most recent years here, we can see the run of the dry years. So this is rainfall turned into primary production. Only one year here that was sort of average. Apart from that, they're all looking pretty ordinary, and why people are hurting at the moment. So if we looked how they are for a 6-year period, that's why we're hurting at the moment, and hope that breaks soon. So if we wanted to look at different sequences and different years, different periods, we'd go to the Aussie Grass website on long paddock here on this tab here, and we explained this last webinar that you can pick whether it's Australia or down to the States. You can pick the period from 1 month up to 3 years. You can pick the variables here of rainfall, pasture growth, grass fire risk, runoff, number of variables there on the drop-down menu, and pick the year there as well. And then you've got the choice of picking a GIF map, a PDF map that will come up, or spatial data for any of that data that's available there. Okay, moving along, we come to the map app, the poster visualization that we've just released. So we're back to the rainfall poster page. Here's the tab up here that we've selected. So we've talked about everything in the rainfall posters, but having 4 posters on your screen or in front of you is somewhat arduous to relate, and we recognise that. So we've made up an application. By pressing this, you will come up with a screen here that relates that the visualization allows you to view each wet and dry period as a map carousel moving along with a mouse click or switching between rainfall and pasture mode. And you can view that on your mobile device or a tablet, and it works quite well. You can read more about the visualization and the definitions of like on the sidebars of the posters, or go straight through and open the visualization. This is what you'll see. So this will open up the most recent most recent map, which happens to be a dry situation. We see that because it's related up here. The question mark takes you to the text explaining the map app. We have our percentile legend here that relates your above average percentiles and your lowest years compared to history here on the legend. Okay, what happens from there is we can look at the individual years that make up that particular dry period. Okay, so that's really good to be able to pick the years, and we have some added functionality that we'll show there in a minute. But we have the El Nino, La Nina years, El Nino, La Nina, blue, the neutral years, and you can see which years that are making up the wet and dry periods there. We also have the SOI IPO time series below here, and we can also, by clicking into this toggle here, move to a pasture growth model. Okay, so see that move to the pasture growth, and we can move that backwards and forwards, and we can see the difference of the rainfall of that 6-year period to the pasture growth period. Now, as I should have said before there, it's not to say that in those periods that you can't operate, but certainly in these drier periods, you know, if there's investment to be made, knowing that you're in these phases, you could exercise some caution in investment, whereas the wetter periods you would service debt more easily with more units of production and more quality of production than in these drier periods. So just urging some conservatives in the drier periods, and that's good information to know. Now, if we go down to the individual maps again, if we pressed on one of those, it brings up the actual rainfall, annual rainfall year, and the pasture growth map side by side there. If we move from along to any one of these maps, it'll do the same. So we can see the rainfall pasture growth annual year, and then we can flick back to the wet dry period by going onto this button here. So that's pretty useful, I think. On the sidebar, which we can't see at the moment, you'll get the text of the social, climate, and economic contextual historical information, and that's the same as it's on the wet and dry poster. So that concludes the rainfall poster detail. Suffice to say that the historical sequences of rainfall and pasture growth can assist us to understand the past and can help us to prevent this repeating previous poor decisions. You can see our posters in the map app on the Long Paddock website at the usual URL address there. You can email us at longpaddock, all one word, @qld.gov.au if you want hard copy posters sent to you at all. And our next in the Getting the Inside Edge webinar series will be our forage couplet, free property information to assist with grazing land management decisions. The first one will be on the currently available information, Thursday the 15th of November. The second will be on the new and soon to be released information on Thursday the 29th of November. Any questions or suggestions, please email us at the Long Paddock team at that same email address. Thanks.